Yeah, hi everyone. I'll take a moment to introduce myself first. My name is Jan. My background is in building Java applications, Java and Kotlin, JVM in general in large enterprises. 5 years of that, I've been building event-driven microservices and using Kafka on the client side. Roughly a year ago, together with a few colleagues, we decided to build a consulting business focusing on data streaming and bringing the developments of the industry to the enterprise customers. And as part of the activities connected to it, I'm here, but I'm also actively publishing on LinkedIn content, and a lot of this has been published in written form as well. This presentation I will structure as a story to hopefully make it a bit more interesting and add more drama to it. It's a story of a development team that is suffering from success. They are building something interesting, and more people are trying to use it and use the data, and because of this, they are facing certain issues. The story is fictional, however, it's really a compilation of my experiences across many different projects. It's structured in a way that I will be talking about three aspects: schema management, data contracts, and streaming data products. But really, these problems are large problems, large clusters of problems and solutions. I really want to structure this as decompose it into specific problems that specific parts of this idea clusters are solving. And the core problem at heart that I think connects all of it is how do we provide more value to our data consumers? As a context, I want to put something that's not directly connected, but it helps to, I hope, grasp what we'll be doing here. Medallion architecture. This is a popular way to structure data in the analytical plane. And the way it works is that you have 3 layers, simplifying a bit. You have the bronze layer when you have raw data ingested as is from the operational systems. You have the silver layer where you have cleaned up and structured analytical data sets. Here you also usually see schema enforcement. And the gold layer that these analytical data sets are transformed, enriched, and so on into to serve specific business objectives and use cases. Yeah, so this was the context. And shift left is kind of something that Confluent has been writing about for years, which is like maybe we take on more responsibility on the side of the operational systems and dev teams and produce higher quality data from the beginning. So our story starts in a small logistics company that's running a system that is a monolithic application publishing Kafka internally. We have a logistics service, drivers that pick up deliveries and then either scan something or set something in the mobile app. And the status changes are sent to the backend system. And we have an internal Kafka topic that is used as kind of a messaging bus within the application. At this stage, we don't really need schemas because we have a monolith, right? So producer and consumer are in the same application. We don't have the decoupling in any way. So we don't really need schemas. I probably would be using them anyway because I'm so used to it and it's natural to me, but there is no strong incentive to introduce them at this stage. The problem arises when we get a request, and I got that request more than once, that analytics have found out that we are using Kafka and they would like to ingest data from Kafka. Instead of just getting CDC from, or maybe not CDC, but ingesting the data directly from our database, they want to use data from Kafka as well. That's great because Kafka Pulsar is great for this, but this means that our topic is no longer internal. So the producer and the consumer are decoupled and they have separate deployment cycles, which means that it's really beneficial to introduce schemas at this stage. Because if we don't, then we don't really communicate what's in there and we'll have significant problems. So in this story, we are building a basic setup at this stage. The setup where we have schemas within our monolith repository. During the CI/CD process, we deploy them to schema registry and then worry about it later. In the beginning, we don't use schema evolution, so we treat every change as a breaking change. So we create a new topic to keep the new structure of data whenever we want to migrate a schema. And because we have this manual process, we manually notify analytics ahead of time that there will be a schema change. It's best if they get ready so that we don't have any issues. But as with every manual process, at certain point, somebody forgot about it, and we had an outage. Not really a huge outage, but somebody forgot it, and we had a production deployment. It was scheduled. We knew that analytics weren't ready for this. We went with the deployment anyway. In this case, we didn't really have a business impact. It's just the data pipelines were down for a day or two without a huge problem. But it was significant enough that we started thinking about maybe solving this problem more properly. Yeah, and we start at the introduction of schema evolution. There are two important aspects to schema evolution. What it is in the essence is we have a subject that's registered in schema registry, and then we have subsequent versions of the schema. We evolve the schema assigned to a given subject over time. And there are two attributes to it. One is the direction. This is what you see on the slides, backward, forward, or full. With Kafka, the default mode is backward. This means that the future schemas that will be assigned to the subject will be able to deserialize all their messages. This is a good setting when we are receiving events. Here, the consumer migrates first, which in event-driven architecture terms, it's for commands and queries. This is where the owner is the receiver of the messages. In our case, a better direction will be forward compatibility. This is a setup where we publish data where producer migrates first, and then all their schemas can kind of catch up whenever they feel comfortable. This is good for events and documents or state, publishing state to Kafka. There is also full compatibility mode, which I haven't ever used in production. Because it has some valid use cases, but they are niche, right? If you solve the problem of event ownership correctly, then most of the time you will fall into like one of these two directions, and this will be the right way to solve the problem. However, again, there are valid scenarios that might require full compatibility. It's just that they are niche. And something I want to highlight is that even though you might evolve your schema in a compatible way, doesn't mean you should. For example, if you're publishing an event and adding a new critical field, and you know that your consumers will be able to serialize it without migrating, but this would mean that they lose data, this is something that you might want to break compatibility explicitly or somehow orchestrate it in a different way so that you make sure that data is consumed with the proper schema. Where I'm going with this is that it's worth understanding all of this, how this works, and there is no default answer on whether you should break it or not. Just need to understand what the consequences are. And yeah, another point is that each of these modes comes with certain constraints that will influence the way you can evolve your schemas. So this is why full compatibility is the most restrictive in this manner. So direction is one thing. Another is transitivity. Transitivity means that by default, your schema evolution mode is not transitive, which means that in this scenario, the orange one is a bit older schema that was used to serialize a given message, and the current schema right now is the purple one. With not transitive, okay, this doesn't display well the blue one, but with non-transitive dependency, you only compare against the current schema. This means you only have guarantees that you are compatible with the current schema and not with all of the older schemas. This is not a good default setting if you have long-running, quickly evolving streams, because there are valid scenarios where A is compatible with B, B is compatible with C, but A is not compatible with C. So transitive is the default way to go pretty much always. And then like two real choices you make are, do you want forward or backward transitive compatibility type on a given subject. Yeah, so this was schema evolution. Now we have defined schema evolution. We have a bit more control over how our subjects evolve. And there is a new challenge coming from the business. We used to have a monolith. We no longer have a monolith. Right now we are introducing a new service that will be used to track the position of our deliveries, our packages, and will report the position to Kafka in real time. This means that it's no longer straightforward to keep the schemas in our single repository. With 2 services, that could be manageable. But if we get into 5 services, then you have schemas scattered over 5 different repositories. This just doesn't scale very well. So there is a best practice. I've published a little bit about it and got some feedback from people doing this. And I wasn't as confident as I am right now when I started this, but I think that I consider a dedicated repository definitely a best practice. So what you do is you define a shared repository for a given scope. This can be a domain, which is a great way to approach it, but this can also be a product or a team, however you want to compartmentalize, and to keep your schemas there. This repository, you integrate with Kafka so that you can provision and configure topics. You integrate it with schema registry so that you can deploy schemas there and, in general, manage everything in a declarative manner. What is really important for the developer experience and general efficiency, so cost, and also developers being happy, is that it's also well integrated with the services that are using it. Because if you do it right, then you're like, one problem I have with schema management is that a lot of people consider it complicated when it really isn't. The workflow that you can get is that you open a PR in the schema repository, it gets deployed, and then you bump the schema version in clients, and everything just works. You need to merge it and navigate it a little bit, but it really boils down to this. I used Maven as an example because in JVM, this is the way you would do it. You would build a jar with a schema library. But if you are not in the JVM ecosystem or want to go to multiple ecosystems, you might use a dedicated repository or maybe use directly the Git repository where you keep the schemas, depending on your technology stack. And I've published a little bit about it. And in the process, I found out that there are 3 open source solutions that implement this pattern. I've built this like custom code 3 times in my life, and now I know that there are open source frameworks, which is great. GCO is the most adopted one, and I got feedback from people using it, and they're happy with it, so that's great. Yeah, and it really is the best way I know how to manage all of this, and very, very universal solution. Another request from the business is that, yeah, we were managing different event types, right? We are tracking our deliveries and want to communicate it. So far, we just had a status, but now they want us to implement different event types and maybe introduce some more complicated business logic. So we have different event types. We have one topic. So we have 2 choices on how we can manage this. One choice is that default for many people I talked with is that we keep our events in separate topics. This is good for isolation, but this means that if we want to preserve the order of events, we would need to deal with reordering on the client side and event time semantics. So this, while it has advantages, it introduces a lot of complexity on the clients. Another approach is to keep them all in a single topic, which also has downsides, because this means that consumers will consume all events that are there, right? So it's there is no default answer, but this is it just important to understand the consequences and options. In our case, we decided to preserve the order and make it simpler for the developers. Something that came up during the discussions was that we wanted to keep the event schemas separate, and we wanted to be able to evolve them independently, which is a bit of a challenge. I will maybe explain this one slide later. In schema registry, in Kafka schema registry, there is this concept of subject name strategy. Subject is something you register in schema registry and assign subsequent schemas to the subject. By default, your subject is your topic, right? And this is the first subject strategy that was introduced and by far the most used. However, there are 2 different ones. One is record name strategy, where your subject is your event type, which means that here you can actually keep the schemas and subjects independent and just have multiple subjects per topic. And topic record name strategy goes a bit further. It lets you have one schema and register this, like have this one type used in 2 different topics and then evolve them independently. Because if your subject is just your record name, this means that if you evolve the schema assigned to the subject, this means that you affect both topics at once, which is not as decoupled. So this one is great. However, it has problems when deserialization. It will be easy for you to write to this to the topic if you use this strategy, but you are really publishing an unknown collection of possible types. And also, while you might be able to deserialize this in your application, many technologies that are consuming from Kafka, like Kafka Connect or other everything that integrates with Kafka on the consumer side, they might have challenges during deserialization because you are not using the default topic name strategy. There is a good solution to this problem, and you will not face this problem everywhere, but this is a bit challenging one. And the solution is a union schema, where you use the topic name strategy for the topic, but you keep references to subjects registered in schema registry. This gives you the best of both worlds. It lets you keep the subjects in separate Avro schemas in your Git repository. It lets you evolve them independently. So if you want to break compatibility, you might break it on only one and not all of them. And it explicitly states allowed record types. And also, very important, it's deserialization friendly and allows you to, very important, preserve the event order because you're keeping the events essentially in the same partition if you use the same key. There is one catch. Confluent schema registry, which is API, which is adopted by almost all of the schema registries in the space, doesn't allow you to explicitly use the version when you publish. So you might have some challenges depending on your technology stack when you use the GitOps approach to implement this approach. I'm saying this as a warning that you cannot just take this solution and implement it. This might require some additional complexity if you want to do GitOps with it, depending on your technology stack. Yeah, okay, so schemas are talking about serialization, right? You explicitly define how to serialize and deserialize the data you publish. The next challenge is coming from the demand. We are getting popular. People find out that we are working in a logistics company. We're publishing the positions of everything. So this is pretty critical piece. People are interested in access to our data, and I will rush through this part because this might be obvious at certain level of maturity of the development team, but documentation becomes pretty important here because if you don't provide good documentation, people will start bugging you for answers, and you just will be forced to implement good documentation. Self-service access as well. At a certain point, you might decide to codify parts of what you document about your system. And this helps with reducing the overhead that comes from popularity. Another aspect that actually allows you to reach more people that could derive value from the data is using data catalog. And there are many open source, closed source data catalogs that support the problem of data discoverability. These are typically like UIs where you register your data sets and register metadata about them so that you don't rely on word of mouth to reach your consumers, which is good for small companies, but in a global enterprise, this means that people will find your stuff way later. Okay, we got popular, and at this stage, one of the business owners in a different department found out that there is an external partner that would like to, they're very interested in integrating with our data and consuming it and maybe paying for it. But they have some requirements. They would like to sign an SLA on data quality, and they would like to have more explicit information about what data is valid and so on. It doesn't need to be an external consumer. This could be just, for example, a business critical consumer internally. But what comes here is the requirement for more structure and more information, more explicit information about what's exactly in there. And here we cross into the area of data contracts. And there are many different implementations, many different standards. Everybody's doing their own thing. So this is a problem in this space. However, the concept is pretty abstract. You can do this without using any tools to support it. What it boils down to is explicit and verifiable codified commitments on the side of the data owners to the users of the data. Sometimes you are the producer, sometimes you are receiving commands and you commit to responding within a second or something like that. But yeah, more commitments, more taking accountability for more as a way to deliver value. And there are a few aspects of it that are popping in here and there, but something that's always everywhere is the semantic rules, which means that we no longer say that this is an int, but we say that this is an int in the range of 1 to 180. And if you deserialize a user that is aged 230 years old, This means that we have an issue, right? This is not valid, and you might block this kind of data from even being published. You might just highlight it on a dashboard to the users after the fact to visualize the health of your services. It's really up to you. Yeah, so semantic rules are everywhere. Something that's connected to everything is using Google's Common Expression Language. The standards are all different, but Common Expression Language is really used by Confluent, Conductor, and Buffstream. So it seems that at least the ecosystem aligns on this part of it. Right, so schemas talk about serialization. Data contracts talk about data sets and allows us to define pretty clearly about what's to be expected in the data set. Now we'll cross into the area of data products and specifically the streaming parts of it. But before I do, I want to mention stream table duality. The idea that you can project the stream as a table and you can represent the table as a stream of changes to this table. Because Kafka and Iceberg, this is something that everyone has right now, and this is emerging for a good reason, because streams are great for appending stuff to the stream at the end, and are great for sequential reads at the end of whole objects, right? So event-driven messaging, this is what streams are great for. What they are not great for is query support. This is where tables are really good, because tables usually come with a lot of indexes. I mean, your call, but this is what they are built for. I mean, there is one hack. Tom here is building stuff that kind of allows you to store an index in a stream. There are ways around this, but the core data structures behind it is, there is this duality. So in our case, what we see is that, yeah, we are publishing the delivery status change, and it seems that 3 different teams are projecting this data into Iceberg, right? Because they know that the stream is there and they need to access the data from Iceberg. What might be obvious once you see this, but you might not find out immediately. What seems obvious that, yeah, maybe we could deliver more value by doing this for them. And this delivers value in 2 aspects. One is efficiency, because you no longer run 3 stream processors or whatever. But also you don't need to bother like 3 teams with building stuff all the time and maintaining this integration on stuff that they are really not that interested in, because this is not their core domain logic. So efficiency is one thing, but data quality is another. If 3 or 5 teams are building the same thing, somebody will eventually make a mistake. Iceberg is straightforward. It's now well supported, but if more complicated integrations come in, then this might be an issue. So in the data product language, I saw 2 terms that describe this concept. One is output ports, another is access modes. Because what you see here is that we have the same core data set, but we, without a meaningful semantic transformations, we project this into different aspect modes, access modes. In the example here, you can see Iceberg, Postgres, dashboard, and so on. What is important to think about is that if you take ownership of this projection, you need to take care of the availability as well, right? If you project this to Postgres and turns out that you have a huge demand, you are responsible for making this Postgres highly available, which means that either you design it in a specific way or introduce certain throttling or anything like this because you take ownership. And this is how you deliver value, by taking more ownership about the way this data is being used. The second important aspect of it is that, yeah, we have a pretty raw data set. That's great. We have the position, right? But position is not enough to infer insights. We need to enrich this data in any way, in some way, transform it and join it with other things as well. By the way, this is a real photo. This is the AI one. This is a real house in Poland. I love it. When we talk about transformations, you typically will talk about a separate new data product because you have a different data set at the core. And it doesn't really matter what you call whatever. I just try to help you navigate if you read about it in the future. So here we have a streaming join executed as a Flink job that's writing to a new data set. Also, we have one more output port as the Iceberg table, and consumers can use one of those. And something that, if you do this, something that I want to highlight is that I talked about SLOs, SLAs, right? Commitments. In our case, the packet position is the well-governed one, the one that we've built and then maybe expanded into a new one. But if you are working with data sets that don't have SLOs, SLAs, then your output will be impacted, right? You don't know what you can count on, so you cannot give such meaningful commitments. Which is why data products really work well in synergy with each other, because if everybody is explicit and transparent about what you can expect, then yeah, it synergizes really well, because you can build more sophisticated stuff on top of it and then still maintain the commitments that that you've introduced earlier. So this is the last slide and the end of the story, but I want to summarize because the data products is the idea that got popularized by data mesh, but I think the first mention was in 2012 and data mesh was 2019. So it did exist before this, and also data mesh is an organizational transformation, requires a huge organizational effort and so on. Data products you can start building today in your teams. And this is why data products get way more adoption. They are very popular in the data space, in streaming. I haven't seen that much conversation. However, there is some publications. There are some publications about it. It is a decentralized approach to data sharing across the enterprise, where you build in governance into what you own and take more ownership, and then you can leverage these external platforms that support these capabilities, but really you don't need to, right? I once implemented data quality rules just as part of my Java application, and then we were just displaying this on the UI. You don't really have dependencies, like hard dependencies on platform support. You can build this yourself if you want. And I love this term, minimal lovable governance, that's coming from Jarkko Moilanen. He's the author of one of the specifications. I think it resonates with me somehow. And I'm not a big fan of definitions, but I tried to bring you one anyway. I found this 4 attributes of a data product. It will be autonomous, so it runs its own application code. It runs on the infrastructure it owns. Could be cloud vendor, of course, as long as you pay the bill. And it is trustworthy. The semantic rules and in general built-in governance, it serves to build in trust so that the consumers of data don't need to get as defensive and they have more predictability. It is value-oriented, so it's typically in the silver or gold layer of the medallion part. It's very often tailored towards specific use cases and demand. And they are built to be reusable because, yeah, as you saw with the position, right? This is the core data set that can be used in many different purposes. And this way you kind of solve the problem of scalability, development efficiency in total. So this was the last content slide. Thank you all for your attention. And yeah, once again, my name is Siekierski. I publish a lot on LinkedIn. I published a lot of, I think 4 or 5 long posts about schema management specifically. If you are an organization that is about to introduce schemas or are not happy with it, or you know one that I would love to talk to you because I'm formulating a service offering around this space. But really anything related to data streaming, I'm kind of starting out with public activity and I engage happily about everything. Love to hear about problems, like to hear about stories. So this is the end of me talking. If there are any questions, then this is our time.